Let's first look at the command and control challenge that is being led here at NASA Glenn Research Center. Here is NASA's Jim Greiner.
Before this project began, NASA surveyed the industry and other government agencies in order to determine what areas need to technology development for unmanned aircraft to be integrated. Two of those areas were separation assurance, how to keep aircraft away from each other, and the other area was communications, how to make sure we had a reliable, secure communications link between the ground and the aircraft. So we worked with industry to develop the program that we're actually employing today. So what technologies we need to develop and the performance requirements of those technologies to make sure that those systems were robust and sound. So we have been working alongside industry in performing testing to enable those standards to be written for commercial entities to be able to certify equipment to put in unmanned aircraft. Unmanned aircraft are pretty much like standard aircraft that are flying today, although they range from very small up to very large aircraft. But what we're trying to do is take the pilot out of the cockpit and move that down to the ground. So normally there's wires and other cables connecting the pilot to the aircraft. Now we're actually taking that cockpit, putting it on the ground, and we're flying that with a wireless system. So it's really like a fly-by-wireless type of system that we have flying the aircraft now. And so that communications link, which is what I'm developing, has to be very reliable. I mean, just as reliable as those wires that we're connecting it on board the aircraft.
Because the FAA has stringent rules in place about flying in the NAS, the communications team at Glenn is using a surrogate aircraft to help with the tests. Although this T-34 aircraft can be flown from the ground like an unmanned aircraft, there is in fact a pilot sitting inside the cockpit to monitor the flight during this initial testing phase.
In order to fly an unmanned aircraft in the National Airspace System, you have to go through a long process to get a waiver to fly in that area. It's very restricted. I mean, usually sparsely populated areas and areas you may not be flying an unmanned aircraft in the future in. So with us using manned aircraft, we can fly anywhere in the National Airspace System where that aircraft normally operates, and that allows us to test in a realistic environment where we expect unmanned aircraft to actually be flying in the future, rather than being restricted to portions of the desert or something where we may not see a lot of unmanned aircraft flying in the future. We'll be integrating the multiple technologies from the UAS project as a whole together and flying those all as one mission. So there'll be a real pilot at the ground control station developed for this project, as well as my radio link, and then algorithms on board the aircraft for the separation assurance portion of the test. So all of that in concert lets us fly the aircraft, because the aircraft will be in a surrogate type configuration, so the commands from the ground control station will actually be maneuvering the aircraft. So in that, it's a full end-to-end test in a realistic environment. The testing we're doing is helping enable a whole new industry for unmanned aircraft, because without this, civilian aircraft will not be able to fly in the National Airspace System. NASA has all the correct facilities as well as the personnel involved in order to be able to do this testing. There's been a long history with aeronautical communications here at NASA Glenn that we've been working with the FAA and industry on many occasions before, and other centers have also been working closely with the FAA on their particular technologies related to UAS, and those all came together within this focused project in order to bring those technologies to fruition.
If you look at unmanned aerial vehicles of today, one of the biggest concerns comes from the fact that they cannot sense and avoid oncoming traffic autonomously, which clearly represents a significant mid-air collision hazard to other aircraft operating in the same airspace. Here at NASA Langley in Hampton, Virginia, members of the UAS team are working diligently to make this concern a thing of the past. One of the biggest challenges facing the integration of unmanned vehicles in the NAS is separation assurance, or sense and avoid. Understanding these variables and developing the automation to help pilots make the proper decisions while navigating is challenging. Part of this challenge comes in working through integration issues with air traffic control, pilots in the air, and UAS pilots on the ground. With that in mind, the NASA Langley team has put together sophisticated testing environments, which will allow pilots, air traffic controllers, and researchers to work collaboratively in the confines of the Air Traffic Operations Lab, or ATOL. This team is coming up with procedures for pilots from unmanned stations to communicate and interact in the most effective way with air traffic control and other piloted aircraft. Although the ATOL is physically located at NASA Langley Research Center, a component of this work is also being handled by a team at NASA Ames, located in California's famed Silicon Valley. Here, the UAS team is working on both sense and avoid and human system integration.
My area is human systems integration, and so I work on the ground control station where the pilot or the operator sits to control the UAV. And our work with integration in the NAS is really trying to understand what the minimum displays are, what the information requirements are for that operator to safely operate in the national airspace. And so we've been doing work with the FAA, with RTCA, Special Committee 228, to help develop the guidelines for what the minimum information requirements are for UAV operators to fly in the NAS. We're really primarily integrating technologies that exist today and looking how that they come together in an integrated system to be able to address this need. For example, we're taking onboard radars integrated with other surveillance systems to be able to ensure that the operators can perform see and avoid functions that are currently done visually by manned aircraft. And so it's primarily an integration of existing technologies and developing the requirements and testing those requirements to ensure that the UAVs can safely fly in the NAS.
You start with what the UAS is. The UAS is a remotely piloted vehicle. However, there's a lot of safety built around the fact that in manned aircraft, the pilot is looking out the glass and is the last line of defense. Hence, sense and avoid, self-separate. So what we're trying to do is we need to do research to integrate the fact that there's a pilot on the ground performing that function, and how does that integrate with separation assurance. That means the air traffic controllers that are separating manned aircraft safely as you transit through the airspace. How does that play with the primary role of air traffic control? Does it perturb their workload? How does it affect them in their day-to-day jobs as we integrate more aircraft into the airspace? There's also implications of what are the effects on other aircraft that are flying. There's a system equipped on every manned aircraft that's certified to fly over 10,000 feet. It's called TCAS, and this is a last line of defense to prevent collisions. Well, the sense and avoid system has to interoperate with that system. It has to play nicely. So specifically, my team is looking at the barriers and the integration challenges of integrating UAVs that are trying to propagate through the airspace system safely, and how that affects other agents, other users of the airspace, and as well as the regulators, the air traffic controllers that are providing the separation services.
Just a few hours down the road from NASA Ames, the culmination of much of this integration happens here at NASA's Armstrong Flight Research Center. Since the earliest days of flight, this lake bed in the high desert has been used to test virtually every type of aircraft imaginable. This storied research center is where much of the flight testing for the UAS integration into the NAS will take place. The final challenge is IT&E. Here is NASA Armstrong's Sam Kim to explain.
IT&E stands for Integrated Test and Evaluation, and that sub-project deals with taking the research that a project is developing, all the software, the algorithms, the procedures, and putting that into a relevant environment. That relevant environment entails simulations that replicates the real world as high fidelity as possible, but then ultimately we need to take that to a flight test environment and to be able to validate the results. As the word integrated entails, right, in IT&E, the integrated test and evaluation, it is an integrated effort to take all the elements of the 4 sub-projects that are part of the U.S. and the NASA project, and trying to get those into an integrated environment. So yes, we need to make sure that all the systems play together, and more importantly, that they really replicate the real world as close as possible. So ultimately, like I said, it goes from simulations into flight tests. So the research ground control station you see behind me is one of the manifestations of that capability to integrate things. It is a proof of concept ground control station that embodies all the, from the human factors and some of the self-separation technologies that we're developing. It's embodied in this proof of concept GCS. In this RGCS here, we do bring in pilots, so we actually bring in real UAS pilots. In fact, we've not just used NASA research pilots, but we've also used Air National Guard pilots, and been able to have a diverse evaluation of our systems. So yes, we bring the pilots here, they get immersed in the simulation environment, and then we're able to collect meaningful data that says that whether the systems we're designing are present the right information, and whether they can assimilate that data quickly and be able to react to the national airspace flying.
When the integration is complete, many of the so-called dull, dirty, and dangerous missions will be turned over to these UAVs, paving the way for a new, safer way to monitor important tasks. We are not there yet, but it's clear that the UAS challenges that have been laid out are daunting. It is also clear that the brilliant men and women of NASA are rising to the challenge as only NASA can. Thanks to their pioneering work, we will soon have a new type of tool available to humanity that will almost certainly prove to be invaluable by making our world and skies safer and perhaps even better than we ever thought they could be.